exponential equations, today we're going to look at solving log equations. Again, we're going to have two methods. The first method is going to work in one very special situation, and that's if we have a log on both sides of the equation, no other numbers being added or subtracted to those logs, and the bases of the logs are the same. If so if it's a log base something equals log base something, then we can set the insides equal. If the bases are the same, the insides must be equal. So in this one we have a log base 3 of something equals a log base 3 of something. Since everything matches on the two sides, log of base 3, log of base 3, the insides must match as well, and we can just set 5x minus 1 equal to x plus 7. So if on the two sides you have the same exact log, you can just set the insides equal to each other. To solve, I would then subtract x from both sides, add 1, and divide. So if our equation is a log on both sides with nothing else going on, just the log on both sides, and the bases are the same, then the insides must be the same as well, so we can just set the insides equal to each other and ignore the log part of the equation. So in this one I have a log base 4 of something equals a log base 4 of something. So those insides must be equal. To solve, I subtract x from both sides. Subtract 17. And divide out. So I get x equals negative 2. Questions? Solve this example. Okay, so to solve this one, we've got log base 2 on one side, log base 2 on the other side. So the insides must also be equal. Subtract an x from both sides. And add 1 to both sides. And you get x is 6. So this method is pretty nice, but it only works in a really special case, if we have a log on both sides that has the same base. Otherwise, this method doesn't work for us. So we need another method to solve equations in general. Yesterday, when we had exponential equations, we solved them by taking logs, because logs undo exponentials. Today with our log equations, we're going to solve them with exponentials, because exponentials undo logs. So our first step is going to be to get the log alone, and if necessary, if there's more than one log in the equation, we're going to need to combine them using the condensing formulas that we learned a couple days ago. Then we're going to rewrite it as an exponential. So that's what that second part says, where we're going to put each side to the base of the log base, where we rewrite our log as an exponential, the base stays the same and the other stuff switches sides, like we've been practicing since section 4. And then we'll solve for x. It then says check for an extraneous solution. So remember, sometimes we can do everything right about solving a problem, and somehow a wrong answer still pops out of that. In a log, we cannot take a log of a negative number. They don't exist. Remember what our log graphs looked like. Our log graphs had an asymptote here and went out that way. We cannot take the log of a negative number. They don't exist. So if we happen to get a solution that would require us to do that, it's not really actually a solution then. So in this one, there's only one log in the problem. It's not that a log equals a log. The log is all alone here. There's nothing added, subtracted, multiplied, divided by it. So we're going to rewrite this as an exponential the way that we learned in our very first lesson about logs. The base stays the same, and the other stuff switches sides. So the 5 is our base, and the other stuff switches position. So 2 becomes the power, and 3x plus 1 goes over to the other side. And then we want to solve. 5 squared is 25. Subtract 1 from both sides. And divide, so x is 8. Check your solution and be sure that it does not cause us to take the log of a negative number. So 3 times 8 is 24, plus 1 is 25, and so we're good to go there. Questions? This one has 2 logs in it. So our first step is going to be to combine those logs the way we learned to use our condensing formulas in section 5 a couple days ago. So when I have 2 logs added together, how can I condense or smush them together into just one log? Multiply. We're going to multiply the insides. So we learned a couple days ago that a property of logs is that if I have 2 logs added together, I can smush them together by multiplying the stuff that's inside. So I'm going to multiply the 5x times the x minus 1 and put it all together inside of just one log.
Would you write it like that, or would you actually distribute it out?
For now, I would write it like this, but we will end up distributing it. So if you wanted to distribute it now, you could. Now we're ready to rewrite this as an exponential. What is the base of this log? 10. When no base is written, it is our common log with a base 10. When we rewrite as an exponential, the base stays the same, and the other stuff switches sides. And then we want to solve the resulting equation. 10 squared is 100, and we're going to distribute on the other side.
Where'd that first 10 come from?
The base of the log is 10 when there's no base written. This turned into a quadratic equation. So to solve a quadratic equation, we want to get everything on one side set equal to 0. So I'm going to subtract that 100 over to the other side. What do you notice about all the numbers in this problem? They're all divisible by 5, so we're going to go ahead and divide everything by 5. And then solve the quadratic. You can use your quadratic formula if you prefer. I prefer factoring when possible. What multiplies to negative 20? That adds to negative 1. Four and 5, and if I want to add to a negative 1, I need the 5 to be the negative. So then what are our solutions?
X is
5 and negative 4. The opposite of the factors are the solutions. Now we want to check these and make sure that neither one of them causes us to take the log of a negative number, because if it does, it doesn't actually work. We can't take the log of a negative number, just like we can't take a square root of a negative number. So if I plug in a 5, I would get 5 times 5 is 25, and 5 minus 1 is 4 inside of those logs, and that's fine. If I plug in the negative 4, 5 times negative 4 would be negative 20, and that is not fine. We cannot take the log of a negative number. So the negative 4 solution is actually extraneous. It worked in solving, but it doesn't work when we actually take it back to the problem.
Anytime there's a negative number, is it automatically out?
No, we can have a negative solution. We just can't have a negative when we plug it back in. So it is possible for x to be negative. It's just not possible for the insides to be negative. Okay, this one has only one log. It is already alone. There's nothing else going on in this equation except for the one single log. So we're ready to rewrite it as an exponential. 4, and the other stuff switches sides. To the power of 2 equals x plus 3. 4 squared is 16. Subtract and we get 13. And if we plug that back in, it works out just fine. Questions? Go ahead and solve this one. In this one, the log is totally by itself. There's nothing added, subtracted, multiplied, divided with it, and there's only one log. So we can rewrite it as an exponential. 5 to the power of 2 equals x minus 4. So 25 is equal to x minus 4, and x is then equal to 29. If we take that back, it works out just fine. This problem has 2 logs in it. So before we can rewrite as an exponential, we need to get those 2 logs together. When we have an addition of logs, we can condense them or combine them by multiplying the insides. Addition of 2 separate logs turns into multiplication inside of 1 log. Then we can rewrite this as an exponent. 2 to the power of 3 equals x times x minus 7. The base stays the same and the other stuff switches positions. 2 cubed is 8, and I'm going to distribute over on the other side. Subtract the 8 to get everything on one side for the quadratic. And I'm going to choose to solve by factoring. So what multiplies to negative 8, that adds to negative 7? 8 and 1, and if I want it to be a negative 7, I need a negative 8 and a positive 1. Which gives solutions then of 8 and negative 1. The solutions are the opposites of the factors. When we go to plug those in, plug in an 8, I get 8 in the first one and I get 1 in the second one. That works out fine. When I plug in a negative 1, I get negative 1. And that is not fine. We cannot take the log of a negative number. Questions? Try one more of these. When you have more than one log in the problem, the first thing you need to do is combine them by multiplying the insides. Addition becomes multiplication. And then rewrite as the exponential. The base stays the same, 6, and the other stuff switches positions. 6 squared is 36, and distribute the x. Subtract the 36 to get everything together on one side for the quadratic. And solve by factoring. What multiplies to negative 36 that adds to positive 5? Positive 9 and negative 4 will give us the positive 5 and the negative 36. So we get solutions then of negative 9 and positive 4. Solutions are the opposites of the factors. By plugging the negative 9 in the first side, negative 9 plus 5 would give a negative 4. So that does not work out. If I plug in a 4 inside of the logs, I would get a 9 and a 4. So that does work out, but just the one solution. The homework tonight is 43 through 50, not what is printed on your sheet. Okay, your sheet says the same exact assignment from last night. So the homework tonight is actually 43 through 50, still from section 8.6 though.